Good morning, good evening, TS learners. So today we are going to see a beautiful concept on customizing large language models. We all know after the release of the Chat GPT, most of us might have trained how to train the GPT models using our custom database or custom datasets. So that would be our target intention of this particular tutorial, how to train the GPT models using our custom datasets. Okay, that we can actually achieve using something called LangChain. Basically, LangChain is a kind of a framework which will give you a lot of different modules, such that you can actually take the advantage and then finally build your own custom LLM on top of the existing LLMs. So coming here, you can already see what do you say, the different modules that are offered by the LangChain. Example, there are many more than this, like, but I'm just pointing here few of the important modules in from LangChain, like models, the prompts, the memory, indexes, chains, and agents. Models basically refer to the actual large language models like your Hugging Face LLM or OpenAI LLM, or the Llama LLM. So the different standard LLMs that are available, so that has been taken and then given them for our reference. And then the prompt, so if at all you are trying to give a query, so LangChain provides something called prompt templates. So you can create a template and then reuse that particular template in your further process of training or further process of querying the model on top of your data. And then memory is basically used to store the conversation for a longer period of time, so you don't want to lose the history such that the context is lost. So in those scenarios the memory is taken care. Indexes, I'm still not yet used, I am yet to see this. And then coming to the chains, most of the scenarios that we encountered, chaining is not required. But what if suppose you have a requirement where you want to combine two different language models into one and then train your dataset such that you achieve some different aspect of your goal. So that is where chains come into picture. Traditionally chaining is like to link two different things inside your entire pipeline of NLP. So if you want to do those kind of activities, then the chaining is helpful. Coming to the agents, agents are basically what I can say is, if you want to access some kind of a tool set inside the LangChain, then these agents are very much helpful because they have direct access to these tools inside the LangChain. So that is one of the example. And there are two different kinds of agents, like action agents and then plan and execute agents. They take the decisions like whether to take an action and execute an action or not, all these kind of decision kinds of things, so these agents will take care. So basically these are the different kinds of modules available. I know this is very very brief and crisp introduction about all these things, but you can always go into LangChain documentation and then you can find a very good documentation and then code snippets along these different modules, and then you can get a better understanding. But what we are going to do in our session is on the right hand side of this. So we will be providing a folder which is having text documents, or in fact, like for simplicity, we'll only provide specific text document or a PDF document. We will split that particular document and then we'll get chunks and then overlaps. These are the two different concepts. So how many chunks you want to create from that particular document, and what is the overlap period that you should have between these two chunks. The reason being is we should not lose any information between while you create the chunks. That is the reason we are trying to keep an overlap such that like no data is lost. And then you create an embeddings. Basically, most fundamental part of any LLM, okay, any large language model, in fact the NLP is generating an embedding. Starting from your OpenAI chat GPT till Google's BERT or Facebook's Llama, the core crux part of this is creating an embedding. What is embedding is basically if you have a document representing every word or a phrase of that particular document into a vector. So we call that as uh, what I can say is that it's a lower dimensional vector space. Okay, so that means every word and phrase would be represented as vectors, which we call it as embeddings, and then finally create that huge database to store it. And once you start giving a query, that particular query is also again converted into embedding, that is nothing but a vector. And then now you start comparing these two different vectors. How do you compare vectors? It could be like one such simple example would be your cosine similarity. So if you operate on cosine similarity between these two different vectors, you get the similarity score, okay, or the distance between these two different vectors. So that means like if at all like if at all the distance is very lower, then that means like these two documents are matching. Okay, uh, so this whole process of creating a text into chunks and then creating an embeddings and then storing, and then with the query you are finding a relevant document, this part is called as semantic search. Okay, if you expand this semantic search a little bit towards to maintain a context of what the embeddings are talking about, and then how your query is fitting into that particular context and extracting some answer to this particular query, not the document directly, then that will become your chatbot. So that's the whole thing. Okay, and uh, today what we'll do is to utilize all these different models of a LangChain. As I already said, every module has got its own coding that has to be taken care. And then what if suppose a person who is very much interested in creating some NLP application, but he's little bit uh, down towards coding, that means like he don't have too much of experience in coding. That is where I am going to explain something called uh, low code no code strategy. So to implement this particular application, we'll be using something called LangFlow. Okay, LangFlow. What is LangFlow? LangFlow is basically a GUI to implement LangChain. Okay, that means you don't need to code anything with your hands manually, but you should have a good understanding of the concepts such that you can graphically drag and drop those components to create your chain of actions and finally create your own GPT. Okay, so let us see how we do that practically. And then the application that we are going to create while explaining this concept is called what should I do? Maybe like I'll create a profile GPT or a resume GPT. That means like you can train the GPT over a resume, and then you can start asking the questions over the different resumes, and then it can start answering different questions out of those resumes it's been trained upon. Okay, very very useful for HR department. So let's say you have a HR department and your employees have got some resumes and you trained the GPT. Now HR can directly start asking this GPT saying that what is the current role of this guy, what is the current package of this guy, and then what are the technology stacks he is more into, instead of they going and looking into different in-house tools of a company. They can utilize this bot to search different aspects of HR work day in day out. Okay, so let us start uh, by start installing LangFlow. Okay, so LangFlow is already installed in my machine, so it will not take too much of time for it to install or the check the installation already. But in your case, if at all it is not installed, it may take little amount of time for you guys. Okay, so the simple command to install LangFlow is pip install LangFlow. Okay, so it'll take, yeah, it's pretty quick because requirement is already satisfied in my situation. That's what I told. So now uh, how to run it? So you just need to say LangFlow. That's it. So now the server gets started, and then it will print onto the console the host that you need to run. So I'll just minimize, and then let me open my Chrome. Okay, so yeah, so this is how it looks like. So the first you'll have a plain canvas, and then you have a lot of components that are being taken directly from your LangChain. These are the different components that are available in LangChain. So I like dark theme, so let me change to the dark theme. And then now what we'll do is we'll try to build the, what do you say, the profile GPT. Okay, so okay, I'll name this as profile GPT. Okay, and then let us start. So first of all, what you need is basically the PDF loader. That's what I told, right? So that will be under your loaders. Okay, so you just expand this loaders, slowly go down. Yeah, you here you have PyPDF loader. Okay, just drag and drop here. Okay, so this PyPDF loader, so put it here. And then it needs a file path. Okay, let it be for now. And then after this loader, as I said in the architecture, oh, just a second, where is this? Okay, in this architecture, you just, once you have a files, you need to you need to split that, right? So text splitters, so you have character splitter, right? Okay, so character text splitter, so that you can just get it here. Okay, and then okay, okay, fine. And then what you have to do is now we have a PyLoader, and then we have a PDF loader, and then we are chunking and then splitting the text that is coming out of it. But I need to have some standard embeddings also. So only for this particular document, if you create an embeddings, that is of no use. So you should have some pre-trained embeddings as well, right? So if you have those pre-trained embeddings, then you can emboss your current documents embedding into those particular database. Then you can train your large language model on the whole embedding data that you have. Okay, so for which what you have to do is, maybe from OpenAI embeddings, we'll get those embeddings. Okay, OpenAI embeddings we will get it. We will have Hugging Face embeddings also, but for OpenAI embeddings we'll get it, for which like you need OpenAI account key. Okay, so I have my account key, so what I'll do is I'll copy, and then I'll get that. So you just create your own API key for OpenAI, and then just copy that particular key and paste it here. Okay, and if you see here, my separator for each embedding is like dot, and then maybe like I'll little bit make bigger size. Okay, yes, and then I have my chunk size as 1000 chunks with chunk overlap of 200. Okay, you can alter this for better results as well. Okay, but for now I am just leaving it on the default sizes and all. Now once you have your standard embeddings from OpenAI, and then you are chunking and then splitting it, and then you have your document. Now what you have to do, you have to um, create a data store, right? So for which like you have basically in large language models, particularly speaking about embedding database, like there are two different database which are most famous. One is Chroma DB, the other one is PyCon. Okay, PyCon is basically it's a cloud hosted. You cannot run that in no, it's not PyCon, it's called Spinecone if I'm not wrong. Let us check it what exactly that is. Vector stores, Chroma we have, what is that called actually, just a second. Yeah, I think it's Pinecone. Yeah, it's Pinecone only, yes. Pinecone. So basically Pinecone cannot run in your local, so you have to host it in the cloud. So I tried Pinecone, but what is happening is they say currently they are experiencing a huge load, and they cannot grant me a free account. So yeah, they added me into their wait list. So whenever a slot is available for me and they will allocate that, at that time I will try to create the same kind of a video with Pinecone, and then I'll show you. But for now what we'll do is we'll start using Chroma. Okay, Chroma can be run in local also. Okay, so let us pull Chroma. Okay, so it needs a text splitter and then embeddings. Okay, so standard embeddings from here. What we will do is we'll create standard embedding from here, and then a text splitter from here. Okay, and now from here we will give the document to the text splitter. Okay, and then finally once you have this DB embedded into the Chroma database, then what you will get is the embeddings, right? The actual embedding, so which will be nothing but the vector storage info. So that you need to get it. So that one I think it's there in toolkits, vector store info, yes. So this vector store info, you just connect this. Okay, and then type some vector store. So maybe I'll say profile store. Okay, and then this is the description. Description would be your um, um, profile GPT. Okay, finish. Okay, and now what we will do is now we will get our actual large language model. So that will be in LLMs. So I'll be using OpenAI LLM only. Okay, so because I have my key. Okay, so now let me get my key again. Where is this key? Yeah, got it. So now let's put my OpenAI key here, and then let me reduce the temperature to 0.5. So what is this temperature? If you have worked with OpenAI a little bit, you know what is this temperature and all. Maximum number of tokens that are allowed for us to communicate with ChatGPT, and then not in this case it is not ChatGPT, but it is like text DaVinci. So LangChain, basically not LangChain, basically LangFlow did not give many options, yet we don't have the GPT options, at least like GPT-2 or GPT Turbo 3.5 or GPT-4, but we are still relying on ADA and DaVinci 2 and DaVinci 3. Okay, so we'll go for the DaVinci 3 version, and the temperature is like if you say 0, then it is like less random. That means like it's 0% random, and then it sticks to what it is required. But if you slowly start increasing the temperature, that means like you are increasing the randomness inside your what do you say, answer generation. Okay, so that is with the OpenAI. And finally we say vector agent. Okay, let's go here. We have vector store agent. Okay, so this vector store agent needs vector store to be connected and the large language model to be connected. That's it. So with this what is happening is we are done with the construction of the chat GPT, sorry, the profile GPT. So what we'll do is we'll input the file here. Okay, so what I'll do is now I'll take I'll browse through some documents where I have my resume here. Okay, I am feeding my resume. Okay, now what should happen is once you do it right, everything you are seeing these dots, right, these red dots, so all these red dots would start becoming green. Okay, so that means like your chain is complete and it will work now. Okay, now if you see this, all the dots became green, so that means everything started working, and at least like the PDF started chunking this. These two are completed and everything is now green in color. So okay, so now what we'll do is let's try out few things, but before trying, I just wanted to show you the chat GPT. Okay, so let me bring up the interface of chat GPT. Okay, let it ask like what is the um, current designation of Pawan. So obviously it will not know it, but just to prove that it don't know. Okay, okay, obviously this is expected answer, so it doesn't know anything about myself, right? So of course, like to do this I should be foolish. Okay, so but just to show you guys that it is not knowing. But what if suppose it should, uh, I mean like GPT model should know about Pawan. Okay, that is what we have done right now. So to test that, we have a small on canvas testing tool. Directly from here only you can test it. So I'll ask the same question here. Okay, what is the current designation of Pawan? Okay, so let us see what it responds to. So now it's thinking, trying to fetch the information. Perfect. Application architect at Honeywell Technologies. Perfect. Okay, so I'll say now you see what happens. When did he join Honeywell? Okay, he refers to Pawan, right? So it is remembering that particular context. Now you see this, what happens now. Perfect, right? So and now you can see I'll ask different questions. How many organizations did Pawan work with? Okay, see what it does. I think like these two answers are perfect, like they are like absolute 100% correct. So it is like it has read and then passed my previous I mean like my profile very correctly. Worked with 3 organization. Awesome. So can you name those 3 organizations? Excellent. So Honeywell, Nest Technologies and Apps Associates. Okay, and then what are his education qualifications? Let us see what it has done. Perfect. So I have my MTech in data science from BETS, and then I have my masters in computer applications from Osmania and a bachelor's from Osmania. Perfect. So now you got it right. So I can train this on a directory also, and then I can give it some bunch of documents, and then finally we can get the answers for them. And this is not just restricted for profiles, but you can do it for your own corpus of data sets, and then you can take the advantage of it. At the same time, now what happens is once this is done and the training is finished and then you are satisfied with the results, then there is an option provided with this LangFlow here. So you just click on the code, you can get it as a Python API or a literal Python code, so where you have to have a profile gpt.json. So basically you can export this the profile gpt, and then write a description and then put it here along with the API key, and then you can start using, load that particular JSON file, and then directly start coding your normal Python. So that is the low code. This is no code. So that's what I said. It is like no code low code strategy. So anyone who wants to build some kind of a GPT models very quick enough for a POC, yes, LangFlow is your good to go tool. Thank you, and then we'll see some more different kinds of low code no code strategies on these LLMs in the coming series. So if you like this video and the content, please like, share and subscribe, and then stay tuned for our channel for more this such kind of content. Thank you very much. Have a nice day. Bye.